Hi, good evening. I'm Khalida Samrin and I'm from CSCE section. So today I'm here to discuss about n-queens problem. In this, consider n into n chessboard on which we have to place n-queens in such a way that two queens not in a same row and same column and same dynamic diagonal place, and we can place queens on n into n chessboard in n factorial ways. For the n queens problem, today I'm taking an example as 4 queens problem. In 4 queens problem, consider 4 into 4 chessboard on which we have to place 4 queens in such a way that no 2 queens on same row, same column and same dynamic. In this we can place queens on 4 into 4 chessboard in 4 factorial ways, as you can see above. For solving 4 queens problem, as you can see in step 1, place queen in a row 0. And so far move to row 1, and in step 2 place queen in row 1 in 0 column, same column will occur, so we will not place there. In try column 1 diagonal conflict will occur, so we will not place there, and try in column 2. So here step 2 will continue. And then in step 3 place queen in row 2 in 0 column diagonal with 1, 2. In try column 1, same column as 1, 1. In try column 2, same column as 1, 2. So we can place the queen in try column 3. So move to row 3, and in step 4 place queen in row 3, as you can see above. And then we have the valid solution and final solution for it. So after all this, let's verify no same columns, no same rows, no diagonals threatening each other. Then we'll have our final solution in it. And then after, you can see above, this is a state space 3 for 4 queens problem, and also this is an algorithm for n queens problem. We can solve 8 queens problem and also 16 queens problem by the way. Let's see the algorithm explanation in this. Firstly, you are trying to place n queens on an n into n chessboard such that no 2 queens are in the same row, no 2 queens are in the same column, and no 2 queens are in the same diagonal. Coming to the function, firstly n queens in bracket k comma n, this function tries to place a queen in kth row, one based indexing for a board of size n into n. And after that, in the second line, try to placing the queen in every column I from 1 to n in the current row of k. After that, checking if placing the queen at in bracket of k comma I is valid. This is handled by the place function. And after that, if it's safe, store the position in array index of x in square brackets, where x of in square brackets k is equal to I, means row k has a column in row I. And then if UV successfully placed queens in all rows 1 to n, print the solution. Otherwise, recursively try to place in the next row k of plus 1. After that, this checks whether placing a queen at row k or column I is safe. Check all the previous rows j from 1 to k minus 1 where queens are already placed. And after that, if a queen is already in column I, it's unsafe. If a queen is not on the same diagonal, it's also unsafe. If any threat is found, return false. If no threat is found, it's safe to place the queen. And for example, let's say n is equal to 4 and you are trying to solve the 4 queens problem. This backtracking algorithm will try to possibility for placing queens by row. Backtrack if it hits a dead end at conflict, and eventually find all valid configurations. Thank you for doing this.